Well, hello once again. This is getting to be a habit. Get yourself subscribed to keep informed of when we release the next one. There really is a lot to talk about, and it does help us with the numbers. I'm Steve Hunt of Ener-Vate, and we are here to talk about and familiarize people to heat networks. That's the aim. In the last video, we looked at what the physical answer is when somebody's asked to describe what a heat network is. That's what most people would expect when they're asked to describe one. Physically, what is it? What does it look like? You talk to a lot of people, they start to talk pipes and they talk about engines, that sort of thing. Well, simply, it is an energy center, it's a distribution pipework system of some kind, and a delivery point. If you've not seen that video yet, go back and have a look at that. Lots more detail in there to catch up on. But in this one, what I really want to talk about is the why answer to what is a heat network, and the reasons why they should and almost certainly will play an increasing role in UK heat in the future. And one of the main things that's cited against heat networks, generally in my experience anyway, is that people are just not used to them. They're unfamiliar to a lot of people. And you know what? You are already very, very familiar with this type of energy delivery. The UK gas network is very similar. It takes gas from a central point somewhere, and then delivers that gas to your home or business to a delivery point, in that case a gas boiler. You then use that gas boiler to create heat to your radiators and taps, and even underfloor heating. The responsibility of the gas network is to provide you gas to the boiler. Well, a heat network is exactly the same. It will deliver heat to your heat interface unit in order for you to create heat for your boilers. It's exactly the same principle. To add to that familiarity, the heat interface unit that I referred to, the HRU, it looks exactly like a gas boiler. And these work alongside a controller and thermostat, just the same as a gas boiler does, to limit the timings and the temperatures and so on. So the familiarity of how that heat is delivered is exactly the same as a gas network delivers gas to a gas boiler. So the next part of this video is why? Why bother with heat networks? What can they do? What's the advantage to anyone or anything? Well, apart from maybe a few of the less enlightened or plain stubborn of our population, I think the majority now know that the greenhouse gas emissions contribute to climate change. And they also know, or it's generally understood anyway, that high carbon fossil fuels such as gas just cannot remain the primary source of heat for UK homes and businesses. So what can heat networks do? Well, for the user, having heat delivered is as close a familiar method of having a gas supply to most UK people, with the absolute advantage that the heat used or generated will be a fair carbon content, a reduced carbon content. It shouldn't cost any more than an alternative low carbon heat option such as heat pumps and so on. And also it can remain flexible in how that heat is generated or sourced, which we'll come on to. So that's for the user. For developers, apart from providing a solution to meet building regs and obligations, a further huge advantage is that the precious space taken up by plant rooms on site can be utilised for other things like extra apartment space, for example. We'll certainly talk about that type of advantage on another video. And in addition to all that, what other method of heating is able to use heat that is otherwise lost? Yet another reason heat networks are great ideas because they can utilise heat from many and varied sources, which means less new generation, which means more efficient use of all our resources. Some examples of that: heat networks can use heat from data centres. There's already a lot of data centres about, and they will only increase in number as we transition to the AI future world. They can utilise heat from energy from waste plants or industrial processes that would ordinarily be lost. One image I always have in mind is of driving through cities, and you see huge flues of factories and processes expressing heat into the atmosphere. You see them all over the place. And these are situated next to loads of buildings, all merrily burning gas, generating heat. It really annoys me. It really does. I mean, just think of that. It's crazy, isn't it? Just ludicrous that we even reached that position in the first place. Heat going up the chimney in one street, gas burning to create heat in another. It's crazy. And you know, heat networks can even utilize heat from sewers. Don't worry, I know what you're thinking. Believe me, it's only the heat that's extracted from the sewers, but another source of heat that can be utilized. So all these can be used, and therefore the heat does not need generating again. It's already there. I mean, come on, guys. Let's utilize the heat that's already there. It's analogy time. I'm only the second video in here, and I'm already into the analogy. I'm an analogy guy, bear with me. But here we go. Why buy apples at the shop? You've already got an apple tree in the garden. Any good? Well, let me know in the comments if it was any good, or even if you've got a better example of that. Because the simplicity of an analogy really appeals to me and how we get this message across to everyone, because it just seems ludicrous that we are generating heat all the time when there's heat going up the flues and chimneys every day that would be easily used for heat networks. So to finish off the video, as the old famous film said, what can heat networks do for us? Well, apart from deliver heat to users in a familiar method, be cheaper overall than generating heat yourself, be very low on carbon, and utilize heat that is already using resources and being thrown away instead of generating even more, it can do absolutely nothing. I hope this video has whet your appetite. There's a lot to cover off. See you next time.